Okay, you will learn about the Mega, the two-stack, and subroutine. So this is the last subtopic under assembly language. Okay, and after that we'll continue with C programming. Okay, so in this microprocessor courses, okay, you will learn two type of programming. One is assembly language, and the other one is C programming. Okay, so semua dengar tak saya cakap? Can you hear me, guys?
Dengar, Doktor.
Okay, sorry sebab suara saya tak berapa ni, sebab saya kurang sihat. Sekejap. Okay, so let's look at the module 8, Mega 32 stacks and subroutines. Okay, so let's look what is the stack is. Okay, so stack is a section of RAM. Okay, it's used by the CPU to store information temporarily, which is you can store either you want to store a data or you can store an address. Okay, so actually the stack is one of your RAM, okay, which you're going to store information temporarily. Previously, we already learned that we have a GPR to store information temporarily, but since our GPR only have a total of 32 saja, so not enough to store more data or more addresses into that general purpose register. So to overcome that, what happened is we are introducing another temporary storage data called a stack. Okay, so recall back. Okay, you have a data memory. So this is the data memory. Your data memory can be divided into 3 parts. Okay, one is a GPR and then followed by IO and RAM. So stack is actually, okay, is your RAM. Okay, so the stack is actually is your RAM. Okay, so this one here is another location which you're going to store information temporarily. Okay, so the CPU needs this storage because there are only limited number of register. Okay, as I mentioned earlier, our GPR only have a total of 32, so not enough. Okay, tak cukup untuk store all the data, all the addresses. So what you need is we're going to have another extra memory, temporary storage data. Okay, that is called as a stack. Usually, a stack is a last in, first out buffer containing a number of data item usually implemented as a block of n consecutive byte long words in a memory. So actually, the stack usually a last in, first out buffer means that whatever you put the okay, it's something like this lah. Okay, paling senang sekali. What is a LIFO, last in first out? Okay, kamu ada satu kotak. Okay, and then inside of that kotak you're going to put a books. Okay, so let's say lah kamu ada 4 buku. Okay, the first book you put in the kotak is buku bahasa. And then you put the mathematics there. The second one. Third one is English. And fourth one is contoh lah, this is your novel. So okay, this is the first that you put, second, third, and fourth. Okay, so what happened is in order to retrieve or to keluarkan this buku here from this box, what happened is you need to pull out the novel first and then followed by English, mathematics, and Bahasa. So that is what the LIFO do. Okay, last in, first out. Okay, means that the last buku yang masuk dalam box there is a novel, become the first one that will coming out from this box. So similar to stack, the last data that you put to your stack become the first data that will coming out from your stack. Okay, so the address of the last data in item placed into the stack is pointed to by the stack pointer. Okay, so since we are going to store a data inside our RAM, so there is one register called a stack pointer to point out where we put that data. Okay, so kita akan ada satu register called a stack pointer to point out the address where we put the data inside our stack. So the application of stack, either you're going to temporary storage variable, okay, you're going to temporary storage data, or you're going to temporary storage of program address. You can put the addresses inside of your stack as well, or a communication with a subroutine. Okay, so this is the last one here is the must lah. Okay, every time you're going to use a subroutine, so you need to have a stack. Okay, then next we are going to see how the stack are accessed in the MVR. Macam mana kita nak guna pakai this stack here. Okay, so since the stack is a section of RAM, so it needs a register inside the CPU to point to it called a stack pointer. As I mentioned earlier, okay, so the stack pointer is used to point where you're going to put the data or where you're going to put your address inside of your stack. Okay, so the stack pointer is 16-bit wide and is implemented as a two register that are SPL and SPH. Okay, since the stack pointer adalah 16-bit, dia punya size adalah 16-bit. Since this is a 16-bit, you can divide it into 8-bit by 8-bit, which is 1 byte and by 1 byte. Okay, so this is a 8-bit or 1 byte, and this is a 8-bit, another 1 byte. Okay, so this one here we call it as a lower byte, and this one we call it as a high byte. So the high byte we call can be labeled as a stack pointer high, and this one is a stack pointer low. Okay, so stack pointer can be divided into 2 bytes. One is a stack pointer low, and the second one is stack pointer high. Okay, the stack pointer must be wide enough to address the RAM, thus MVR with a greater of 256 byte of a memory. The stack pointer is made of 2 8-bit register or 2 byte register, which is stack pointer low and stack pointer high, while the MVR with a length of 256 byte, the stack pointer is only made of stack pointer low. Okay, since at Mega 32, the size of our RAM is 2 kilobyte, which is greater than 256 byte. So the stack pointer is made of 2-bit register lah. One is a stack pointer low, and the other one is stack pointer high. Okay, so there are two types of operation involving a stack pointer. Okay, untuk guna stack pointer dia hanya ada dua operation. One we call it as a push instruction. The second one we call it as a pop instruction. Okay, so what is the push instruction and pop instruction do? Okay, for the push instruction, okay, you're going to store of CPU information such as the program counter or data or address to the stack. Means that every time you're going to put the data to your stack, okay, we're going to use a push instruction. Okay, so push means that put data or address inside of stack. Okay, this is what the push do lah. Okay, while pop means that you're going to load of the stack content back into a CPU register. For pop means that we're going to retrieve back the data. Okay, you're going to retrieve the data inside of the stack and put it to your register. Okay, so this is a retrieve data or address from stack. Okay, so again, okay, the stack is usually the last in first out, okay, order, okay, buffer. Okay, so this is the instruction that we will use, either push or pop. Push, put data or address to the stack, or pop, you're going to retrieve the data or address from the stack. Okay, so how we are going to push a data on the stack? What instruction that we're going to use? Okay, the stack pointer always point to the top of the stack. Okay, usually, okay, so this is your data memory. Okay, stack pointer usually we initialize at the okay. Okay, so this is your data memory, GPR, IO, and this is your RAM. Okay, this is a memory address. Okay, started from 000 until your RAM N. What is your RAM N value? Berapa kamu punya RAM N? The last address of your RAM for Atmega 32? Anyone? Okay, 085F. Okay, means that usually, okay, to initialize the stack pointer, the stack pointer must point to this address 085F. Okay, so the stack pointer always point to the top of the stack. Okay, as we push the data to the stack, okay, the data are saved where the stack pointer points to, and the stack pointer is decremented by 1. Okay, kenapa decremented by 1? Because you see here, okay, the memory address is from 00 at the top, while the bigger address here, the biggest address is at the bottom. Okay, while you put the data to your stack, what happened? Okay, and then your stack pointer will point to this address, which is it will decremented by 1. So that's why lah, setiap kali kamu push a data to your stack, okay, every time you put the data in your stack, okay, the stack pointer will decremented by 1. Okay, contohlah kamu nak letak value FA ke dalam stack. What happened here? Okay, so now your stack pointer point to address ni 085F. Once you put the data FA to this stack, so the stack pointer now point to this address, which is 085E. Why? Because it's a decremented by 1. So the stack pointer always point at the top of your stack. Okay, tadi mula-mula kita punya stack kosong, tak ada apa-apa. So that's why it's pointed at 085F. Now, the stack have a content of FA. So what happened? Now, the stack pointer decremented by 1, which is it point to the top of this stack here. Okay, so other words, stack pointer is decremented when data is pushed onto the stack. So you need to remember lah, setiap kali kalau kamu put a data to your stack or push a data to your stack, the stack pointer will decremented by 1. Okay, so to push a register or to push a data or addresses onto the stack, we are going to use the push instruction. So this is the push instruction. Okay, this is the syntax, push RR. Okay, in which RR is the value that is from your GPR. Okay, any value from GPR, you're going to put it or store it to your stack. Okay, so this RR can be any of the general purpose register from R0 to R31. For example, okay, you're going to store value from R10 to your stack. So how to do that? Okay, you just simply write push R10. So what happened? CPU akan ambil data from R10, which is this value here, and then put it to your stack. Okay, so this is what the data that the CPU copy from R10, letak dalam stack, and what happened to your stack pointer? Stack pointer now decremented by 1. this is what the push instruction do lah. Okay, you're going to put a data to your stack, and then we have the second instruction, which is a pop instruction. Okay, so the pop instruction is actually popping the content on of the stack back into a given register. Is the opposite process of pushing. Okay, means that the pop instruction means we're going to retrieve the data from the stack and put back to our register. So this is what the pop instruction do. Okay, when pop instruction is executed, the stack pointer is incremented and the top location of the stack is copied back to the register. Okay, means that you're going to take back the value from the stack, put to your register while your stack pointer is incremented by 1. So this is due the stack is last in first out memory. Okay, sebabnya kita menggunakan konsep LIFO, last in first out. The last information goes to the stack, become the first information or the first data that coming out from that stack. So to retrieve a byte of the data from the stack, we use the pop instruction. So this is the pop instruction. Okay, pop RR, which is RR is your general purpose register, can be from R0 to R31. Okay, for example here, you're going to copy value of R60 from stack pointer. Means that you're going to take the value from stack pointer and put to your R16. Let's this is your data memory. Okay, and then let's lah, this is inside of your stack. You have this value. Okay, FA, this is A1. Okay, now the stack pointer point to this address here. Okay, because the stack pointer always at the top of your stack. So this is your stack pointer. This is the address 085F, and this is a 085A, and this is 085D. Currently, your stack pointer point to 085D. Okay, and then let's this is R16. Okay, so now you're going to take the value from this stack and put it to R16. So how to do that? You just simply write pop R16. So what happened to your R16 after you execute this line here? R16 akan ada value from FA, di mana FA ni kamu letak dalam R16. Okay, copy to R16. What about your stack pointer? Okay, the stack pointer now will incremented by 1. Okay, previously dia point dekat address 085D. Now it pointed to new address which is 085E. Okay, so your stack pointer now will point to address 085E. Kenapa saya buat macam ni? Okay, kenapa saya bahagikan dia kepada dua? Sebab yang ni SPH, this is your SPN. Ingat lagi tak, stack pointer is a 16-bit wide. Kita boleh divided into 2 byte, one stack pointer low and stack pointer high. Okay, 5E kita letak dekat low, 08 kita letak dekat high. Okay, so this is what happen every time you pop a data from the stack and put it to your register. Any question up until here? Ada soalan tak? Okay, if no soalan, okay, next we go to the next slide. Okay, so how we are going to initialize the stack pointer? Okay, sebabnya stack pointer must be inside of your RAM. Okay, so macam mana kita nak initialize so that the stack pointer berada dalam RAM, bukan dalam GPR, bukan dalam IO. Sebab this is our data memory. Okay, so this is our data memory, and this is your GPR, this is IO, and this is your RAM. Okay, the stack pointer, your stack must inside of your RAM. So how we going to initialize so that the stack pointer pointed to the address inside of your RAM. Okay, so when the AVR is power up, okay, setiap kali kamu power up your AVR, setiap kali kamu turn on your AVR, what happen here is the stack pointer register contain the value 0. Okay, so every time you switch on your FVR, okay, so this is the default value of your stack pointer. Okay, so this is SP. Okay, so this is your SPL and this is your SPH. Okay, so by default, stack pointer point to this address. 0000. Dekat mana 0000? Okay, kat sini lah. Okay, so this is your memory address and this is your RAM end. Okay, and then this is okay. This is 0060 and this is 0020. Okay, by right, your stack pointer kena point to address from 0060 hingga 085F. But since every time you turn on your FVR, the stack pointer, the default value of your stack pointer is point to this address, which is salah lah. So how you going to make sure that stack pointer, okay, point to the address inside of your RAM? So what you're going to do is you need to initialize. Okay, how to initialize? Okay, by doing a programming. Okay, so since the FVR, the stack grow from higher memory location to the lower memory location. Okay, so which is every time you push data to the stack pointer decreases. So it is a common to initialize your stack pointer to the uppermost memory location. So ideally, we are going to initialize the stack pointer so that it point to address 085F. Okay, that is the most ideal tempat kita nak initialize kita punya stack pointer. Kenapa? Kalau kita initialize kat sini, banyaklah memory ataupun banyaklah temporary storage data yang kita boleh guna. Okay, kalau kamu initialize dekat 0060, yes, it is okay to initialize dekat 0060. Tapi kamu hanya ada satu je temporary storage data kat sini sebab kamu ada satu tempat. Kenapa? Lepas tu, your stack pointer dah masuk ke I/O, which is illegal. Tak boleh. Okay, your stack pointer must point to address dalam between your RAM. Tak boleh dekat I/O, tak boleh dekat GPR. So that's why the ideal place to initialize your stack pointer is to initialize dekat address 085F. So different FVR have different amount of RAM. Those in the FVR assembler RAM end represent the address of the last RAM location. Okay, because ATmega32, the RAM last address of your RAM is 085F. But if you use the ATmega16, for example, okay, the RAM end is no longer dekat 085F. Mungkin dekat 05 something. Okay, kalau kamu guna pakai ATmega 128, the RAM end is somewhere around FFFF. Okay, which is different from one chip to another chip. So macam mana kita nak nak standardize supaya the same code boleh guna di ATmega32 chip, boleh guna dekat ATmega 16, boleh guna dekat ATmega 128, okay, by using this RAM end. Okay, so the RAM end, as every time you use the RAM end, the CPU know that that is the last address of your memory location. Okay, regardless of the chip that you're going to use, either ATmega32, 8 tiny 16, okay, ATmega 16, ATmega 64, or ATmega 128. Okay, so those to initialize the stack pointer to the last memory location, simply load your RAM end into stack pointer. So how to load the RAM end into the stack pointer? Okay, by using, okay, so macam mana kita nak load RAM end into stack pointer? By doing programming. Okay, later in the next slide, we will learn how to initialize the stack pointer. Okay, so that the stack pointer point to your RAM end. Okay, again, just recap, since stack pointer is made of two register, those kita kena load SPH, okay, with the higher byte of the RAM end, while SPL load low byte of RAM end into SPH. Okay, so this is our RAM end. Contohlah untuk Atmega 82, our RAM end is 085F. So SPH stack pointer consists of SPH and SPL. So macam mana nak buat? Okay, so this is the address ya untuk Atmega 32 085F is your RAM end. So macam mana nak buat? This one you can divide it into 2 byte. One is low and one is high. So what happen here? Okay, 5F kamu kena letak dekat SPL, while 08 kamu kena letak dekat SPH. So macam mana nak letak this value to SPH and SPL by doing a programming. Okay, so let's look how to initialize the stack pointer so that the stack pointer point to this 08 5F address. Okay, for example. Okay, this is an example show the stack pointer and the register used after the execution of the instruction. Okay, so first, okay, you include, okay, the empty2def.inc. Okay, why we need to include this file here? Okay, this is very important lah. Okay, every time you're going to use the input-output port, or every time you're going to use the stack pointer, you need to initialize, okay, to include this file here. Kalau kamu tak include this file, what happen is, okay, you cannot use the label. Okay, this is the label. Okay, kamu kena hafal dia punya memory address. So since you include this file here, so now you can use the register name instead of the address of this register. Okay, so this is this is why we're going to include the empty2def.inc file. Okay, then ORG0, so you're going to start your program so that the program is started dekat location 0000. Okay, so the first 4 instruction here. Okay, let's look at this first instruction. Okay, load I R16 high ramen. Okay, dia bagi tahu kat situ load I R16 high ramen. Okay, kamu ada RAM end. Okay, RAM end kamu adalah 085F, di mana 085F adalah 16 bit. Since this is a 16 bit, you can divide it into 2 byte. Okay, one is a lower byte and the second one is high byte. Okay, kalau kamu tengok sini, load R16 high ramen means that you're going to take the value from high ramen. This is the high ramen, the high byte of your ramen, and put to your R16. So what happened? R16 sekarang ada value 08. Okay, before we initialize the stack pointer, okay, every time you going to run this program here, the stack pointer, okay, your stack pointer, which is consists of SPH and SPL, okay, will point at 0000, which is wrong lah. Kita tak nak dia point dekat address ini, which is dekat R0. Okay, so now we're going to initialize so that dia point dekat RAM end. So macam mana nak buat? Okay, mula-mula kamu buat macam ni lah. Load I R16 high RAM end, ambil high value from the RAM end and letak dalam R16. Lepas tu buat apa pula? Out SPH R16. Okay, kamu hantar value R16 tadi, which is 08, masuk ke dalam SPH. So SPH sekarang ada sama dengan 08. So what happen? Sekarang ni SPH, okay, your stack pointer high sekarang ni dah tukar jadi 08. Okay, do we need to stop here? No. Kenapa? Kita kena make sure that stack pointer point dekat address 085F. Currently, stack pointer point dekat 0800, which is not the ideal place lah, bukan tempat yang kita nak. Kita nak 085F, but currently stack pointer pergi dekat address 0800. So what we going to do? Okay, then we load again. Okay, sekarang ni kita ambil pula low remain. Okay, the low byte of remain, which is 5F, put it to R16. So R16 ambil bahagian low, which is 5F, letak dalam R16. So next what happen? Out SPL R16. So SPL sekarang ni akan ada value from R16, which is 5F. So what happen after you execute this line? Okay, kat sini sekarang ni dah jadi 5F. Okay, now the stack pointer initialize dekat address 085F, which is at your RAM end. Okay, so this is the so these 4 lines here is used to initialize your stack pointer. Okay, so setiap kali kamu nak initialize stack pointer, just copy back this 4 line of instruction. Okay, copy dia yang ni. Hafal saja 4 instruction ni. So this is how you going to initialize your stack pointer so that your stack pointer point to 085. Okay, any question up until here? Ada soalan tak? If no soalan, then we go to this one here. Okay, the next slide is load I R310. Okay, so kamu masukkan 0 ke dalam R31, load I R20 OX21, masukkan 21 dalam R20, and load I R22 OX66. So kamu masukkan 66 ke dalam R22. Okay, so this is your data memory. Okay, again, I draw the data memory. This is your GPR, this is your IO. Okay, now after we execute this 4 line here, the stack pointer point to this address. Okay, so stack pointer point dekat address ni, which is 085F. Yes, ini is 085E and this is 085D and etc. And this is your 0000. So this is R0. Okay, this is your GPR, this is your IO, and this is your RAM. Okay, so sekarang ni R31 ada 0. So this is R31, which is consist of 0. And then R20 and R22, you put, okay, which is somewhere around here. R20 and R22, you have 21 dengan 66. Okay, and then next, push R20. Okay, what the push instruction do? Okay, means that you're going to copy the value from R20 and put it to your stack. Okay, so 21 ni daripada R20, kamu letak ke dalam kamu punya stack. Okay, so 20 kamu letak, sorry, not 20, 21. Okay, value 21. Okay, from R20, you put it to your stack. What happened to your stack pointer? Now the stack pointer decremented by 1. So stack pointer now point to address 085E. Then you push another time. Okay, push R22. So you copy value from R22, which is 66, letak dalam stack. What happened to your stack pointer? stack pointer decremented by 1. So now the stack pointer point to new address which is 085D. Okay, then load I R20 kosong, load I R22 kosong. So what happen? Okay, you clear the value from in R20 and R22 so that all the value here become 0. And then after that, pop R22. So what happen when you pop? Okay, the pop instruction means that you're going to take the value, retrieve the value from the stack and put it to your register. Register mana yang kita nak letak? R22. So ambil nombor 66 ni, kamu letak dalam R22. Okay, so dia akan jadi 66 balik. Okay, what happened to your stack pointer? Stack pointer now incremented by 1. Okay, previously stack pointer point dekat address ni. Now it point dekat address 085A. After you do the pop instruction and then you pop another one. Okay, pop R31. So what happened here? Nombor 21 inside of your stack. Now you copy to R31. So sekarang ni kat sini akan jadi 21. What happened to your stack pointer? Stack pointer will incremented by 1. Now the stack pointer point to new address which is 085F. This is how the stack pointer works lah. Okay. Okay, and then this is the what we call here the diagram, okay, of this program. Okay, what happened? Okay, after you execute a certain program. For example here, lepas kamu execute out SPL R16, what happened? The stack pointer point to this address 085F, which is this is the last. Okay, this is the when you do the out SPL R16, which is you already executed these 4 lines here. So that's why the stack pointer point to this address 085F. R20 dengan R31 masih lagi kosong-kosong lah sebab kamu tak letak apa-apa lagi. And then after that you put this value here to your R31, R20 and R22. So what happened? After you execute the last line here, load I R22 OX66. So R20 got 21, R22 got 66, R31 got 0. And then after that, you do the push instruction, push R20, push R22. Okay, so when you push R20, what happened? Okay, ambil value from R20, put to your stack, and what happened to stack pointer? Stack pointer decremented by 1. So that's why kamu tengok ni stack pointer change from 085F sekarang jadi 085A. Push another one, push R22, which is 66. Daripada R22, you put to your stack and stack pointer decremented by 1. So that's why now you can stack pointer change from 085A jadi 085D. Okay, then you do the load I R220 means that you clear all the R20, R22 and R31. And then after that, okay, so this is the stack pointer lah. Stack pointer still remain dekat 085D. And then you do the pop R22. So what happens when you do pop R22? Okay, you're going to take this value from the stack and put it to your R22. So that's why R22 ada 66. What about your stack pointer? Stack pointer is incremented by 1. Okay, by right nombor 66 ni masih ada dekat stack. Dia masih tak hilang. Dia masih lagi ada dekat stack. And then you pop once more. Okay, pop R31. So what happen here is 21 yang ni, yang ada dalam stack, kamu nak letak dalam R31. And what happened to your stack pointer? Stack pointer incremented by 1. So this is what happened from the previous program example. Okay, so this is another ni lah. Okay, so this is another example how the push and pop works. Okay, I just okay, so can you see this one? Okay, so the yellow line here, this is your program counter actually. Okay, once your program counter go to this line here, means that you currently execute this instruction. Okay, you already learned this about the fetch and execute cycle in the module 1 or module 2. Okay, so let's so this is your register. You have R20, R21, R22, and R0, and this is your data memory, and this is your stack pointer. Okay, at the start of the program, the stack pointer is point dekat alamat 0000. Now you're going to initialize the stack pointer so that the stack pointer point to your RAM end. Okay, so how to do that? By doing this for instruction here. So this is what happened lah. Okay. So you enter out SPH R16 node. So now the step pointer point to this. That is not yet your RAM end. So you need to load again. Okay, R60 with low RAM end and out SPL R16. After you did that, what happened? Step pointer point to this RAM end. Okay. and then, okay, after that, what are you going to do? Okay, so now you're going to load IR20 with 10. Okay, so masukkan 10 dalam R20. R20 ada 10. Load IR21 with 20. 20 sekarang ada dalam R21. And load R22 with 30. Okay, so R22 ada 30. Okay, then after that, you're going to push R20 to your stack. Okay, so what happened? Push R20 to your stack. Okay, so value 10 daripada R20, kamu masukkan dia dalam stack. What happened to your stack pointer? Stack pointer decremented. And then push R21. So you take the value from R21, which 20 put to your stack, stack pointer decremented. And push another time, push R22. So ambil value 30 dalam R22, letak dalam stack, and stack pointer will be decremented. Okay, then the next instruction, you're going to retrieve that value from the stack and put it to your R21 by using pop instruction. So what happened here is, okay, kamu ambil value 30 daripada stack, masukkan dalam R21. What happened to your stack pointer? Stack pointer incremented by 1. Okay, pop R0. So ambil value 20 dalam stack, letak ke R0, and then after that your stack pointer will decremented by 1. So 20 daripada stack, letak dalam R0, stack pointer incremented by 1, and pop R20. So what happened? Ambil value 10 dalam stack, letak dekat R20, and stack pointer is incremented by 1. So this is another example lah how the push and pop works. Okay, any question up until here? Ada soalan tak?
Tak ada, Doktor.
Okay, kalau tak ada, now we go to the next slide, which is stack pointer upper limit. Okay, so as I mentioned earlier, we can define the stack anywhere in the SRAM memory. Okay, kamu boleh letak kamu punya stack pointer, or you can initialize your stack pointer dekat your RAM, anywhere inside of your RAM. Okay, but ideally kita nak initialize stack pointer so that the stack pointer point dekat our RAM end. Kenapa? Sebabnya kalau kamu initialize your stack pointer dekat atas ni, what happen here is, okay, kamu punya temporary storage data yang kamu create akan jadi sikit compare kalau kamu initialize dekat bawah ni. So nanti bila mana kamu punya stack pointer, okay, point to address dalam IO, so this is where the overflow occurs. Okay, your stack pointer upper limit you dah exceeded your stack pointer upper limit. So in MVR, the stack can as big as it ran. So why not we initialize the stack pointer dekat bawah ni so that all the RAM here become your stack. Okay, note that we must not define the stack in the GPR nor in the IO memory. So kamu tak boleh letak your stack pointer dalam GPR dalam ni ataupun dalam IO. Kena berada dalam RAM sahaja. So the stack pointer must be set to the point above address 600060 hingga 0085F. Okay, so stack content is important as it's used to store information when we call it a subroutine. So the stack overflow will occur when the content of the stack is exceeded the upper limit. So the upper limit of your stack is dekat alamat 0060 lah. Bila stack pointer point to address 005F now, okay, it already exceeded the stack pointer upper limit, dah masuk dalam IO memory, which is illegal. Okay, so this is why we need to initialize the stack pointer to dekat alamat 085F so that okay we not exceeded the stack pointer upper limit. Okay, so that is for the push and pop instruction. Any question? Kalau tak ada soalan, okay, we are going to look at the subroutine. Okay, sebab sebelum ni, okay, macam yang saya katakan, stack ada tiga, kenapa dia tiga function of stack. One is temporary storage data. Okay, satu lagi kamu nak simpan kamu punya memory address, and the third one here you going to use the stack for the subroutine. Okay, so what is the subroutine? Okay, so subroutine is a sequence of usually consecutive instruction that carries out a single specific function or a number of related functions needed by calling program. Okay, a subroutine can be called from one or more location in a program. Okay, so actually this subroutine here is a program that you're going to call it repeatedly. Okay, kamu nak panggil dia berulang-ulang kali. Okay, contoh paling senang ialah subroutine untuk generate delay. Okay, kamu nak buat LED sequence. Okay, contoh ya, kamu nak buat LED, kamu nak nyalakan LED kamu. Okay, so that LED kamu dalam bentuk, dia akan tunjukkan dalam bentuk sequence lah. Okay, so contoh kamu ada 8 LED yang disambung kepada port D. Okay, so the first sequence that you going to tunjuk papar dekat LED is yang ni menyala. Okay, LED 7 dan 6 menyala, while the rest padam. Okay, this is the first sequence. Okay, and then berapa lama kamu nak nyala LED ni? Contohlah 1 second. Okay, kamu nak nyala LED ni 1 second, and then after 1 second dia akan pergi ke next sequence. Okay, which is 5-4 nyala, yang lain padam. It is another 1 second, and then sequence number 3 is 3-2 nyala, yang lain padam. Okay, this is another 1 second, and sequence number 4 okay, 1-0 nyala, and then the lain padam. Okay, contoh kalau kamu nak tulis program, for example, if you're going to write a program, so this one ya, so LED ni kita sambung ke port D ya. Okay, contoh port D. So what you're going to do here is, okay, mula-mula kamu kena sediakan load I. Okay, the value that you're going to send to port D, so this is the value lah. Contohlah kalau nak nyala LED kita kena hantar 1. Okay, and then padam kita letak 0. Okay, so load I R16 0B 11000000. Okay, so kita masukkan value ni ke dalam R16, lepas tu kita hantar dekat port D. So value ni akan hantar ke port D, so LED ni akan nyala. Okay, berapa lama LED ni nak nyala? 1 second. So kat sini kamu kena buat programming untuk generate 1 second delay. Okay, mungkin panjanglah dia punya programming ni untuk generate 1 second delay. Okay, mungkin 10 line, 20 line, kita tak tahu. Okay, and then next second sequence LDI. Okay, kamu nak hantar yang ni pula. Okay, R16 0B 00110000 and out port D R16. So nanti 54 nyala, yang lain padam. Lepas tu nak buat apa? Kena panggil lagi 1 second delay. So kamu tulis lagi programming untuk 1 second delay. So why not? Sekarang ni, okay, sini contohlah kalau to generate a 1 second delay ni kamu pakai 20 lines. Okay, sini another 20 lines. Okay, so untuk buat 4 sequence ni kamu kena ada 20, 40, 60, 80 line untuk generate a delay, which is you dah wasted too much programs memory. Okay, why not? Because this is the same program, which is to generate a 1 second delay. Why not we just use a subroutine? Okay, which is kita hanya tulis satu subroutine consists of 1 second delay, and then every time we going to generate a 1 second delay, kita hanya panggil the subroutine tu, call that subroutine. So we already save the program memory kat sini. Instead of active program memory to generate this delay here, so now you will reduce around 60 lines. Okay, sebab kamu hanya guna sekali je, kamu generate a delay and then you call it over and over and over. So that is why we going to use the subroutine. Okay, which is the program that you're going to call again and again. Why not we make it as a subroutine and we just use the call function to call that program. Okay, so actually this subroutine is slightly different from branch or jump, di mana branch or jump that you learned earlier in module 7 okay, sama ada BRLO ke, BREQ, BRNA, kamu takkan patah balik tempat every time you buat branch ataupun jump. But subroutine, one is jump to the subroutine, okay, and the subroutine is finished. Okay, once dia pergi lompat ke subroutine and do all the coding inside the subroutine, and once finished, dia akan kembali semula to the place after you call the subroutine. So this is the difference lah using a subroutine and jump and branches. Okay, why subroutine? To use the same set of instruction sequentially. Okay, to use the same set of the program repeatedly. Okay, kamu nak guna benda yang sama berulang-ulang. So that's why we use the subroutine. Okay, so subroutine dia ada dua instruction untuk guna subroutine. One we call it as a call instruction and satu lagi we call it as a RET instruction. Okay, call instruction means that you're going to call a subroutine, means kamu nak lompat ke subroutine kamu, do all the coding, which is for this example lah, do all the 1 second delay punya programming, and bila finish, dia akan return kembali semula buat the following instruction. Okay, so let's look at the subroutine call instruction. When a subroutine is called, okay, every time when you call the subroutine, the processor first save the address of the instruction just below the call instruction onto the stack and then transfer control to that subroutine. So every time you do the call instruction, what happens is CPU akan ambil address, okay, of the next instruction, okay, address untuk instruction yang ni, dia akan simpan dalam stack. Okay, dia akan simpan dalam stack. Okay, and then once dia dah simpan address next instruction, okay, barulah dia lompat ke subroutine ini. Kenapa dia nak simpan address next instruction? Because lepas dia finish everything, dia nak kembali semula dekat instruction yang ni. Okay, so once, sebab kita dah simpan kat sini, nanti kita akan pakai semula address ni so that kita boleh return dekat instruction ni. Okay, so this is what happen every time you do the use the call instruction. Okay, so call is a long call to subroutine. Okay, so this it call to a subroutine within the entire program memory. Okay, the return address, okay, to the instruction after the call will be stored onto the stack. Okay, every time you use the call instruction, okay, before you go to that subroutine, kamu kena simpan dahulu next address of the next instruction, okay, the address of the next instruction to your stack, and then after that you can go to that subroutine. So this is the syntax called K. K is the address of your program memory. Okay. Okay, contohlah kat sini. Okay, so this is a subroutine call instruction. Okay, so move R60, R10 and then call check. So what happen here? Okay, mula-mula kamu ambil dulu address NOP instruction ni, letak stack ke dalam stack, and then after that you go to this subroutine check. Do all this thing. After that, every time you see the return, then you will return to NOP instruction. Okay, next subroutine RET instruction. So what this RET do? Yang ni kat bawah ni, apa yang RET ni buat? Okay, RET ni maksudnya kamu nak return from subroutine, means that you already finish the subroutine. Kamu nak kembali semula ke tempat yang kamu, okay, ke tempat yang kamu selepas kamu buat call instruction tadi. Okay, when the execution of the function is finished, okay, bila that subroutine is finished, the RET instruction at the end of the subroutine is executed. The address of the instruction below the call is loaded into the PC. Okay, so tadi kan every time you call instruction, so what happen? Address of the next instruction will be stored to your stack. And sekarang ni, bila kamu CPU jumpa je RET, so what happen? Address ini CPU akan letak pada program counter. Okay, CPU akan ambil address ni, letak pada program counter. Now the program counter know, oh now we need to return back to this instruction after we call that subroutine. Okay, so sebab itulah dia kembali semula dekat instruction yang ini. Okay, so this is what the call and RET instruction do. So RET is stand for return from subroutine. The return address is loaded from the stack to your program counter. Okay, so this is the syntax RET. Okay, so okay, so this is an example macam yang sebelum ni tadi. Okay, so you call check, what happens sebelum kamu call check, ambil dulu address NOP instruction, letak dalam kamu punya stack. Okay, contoh this is SX, you put back to your stack and then baru lompat ke check punya subroutine, do everything inside of the check subroutine, and then suddenly the CPU execute a return. So now what happen is this address here akan load ke program counter, and program counter now will have this address, or now the program counter know, yes, now we need to go back to this location which is NOP instruction, and then it will turn back to this location. Okay, so this is the role of stack in the subroutine. Okay, stack is used to temporarily store address. Okay, previously we store the data in the stack, but for the subroutine we store the address. Okay, So stack is used to temporarily store the address when CPU execute the call instruction. So this is how the CPU know where to resume when it returns from the call subroutine. Hence, we must very careful when manipulating the stack content. Okay, so every time you're going to manipulate the stack content, make sure that you need to be extra careful. Okay, because you doesn't want to mix up with your stack content. Nanti kalau kamu mix up with the stack content, what happen? If you do the subroutine, dia tak akan kembali ke tempat yang sepatutnya. So that's why you need to very careful. So for AVR whose program counter is no longer than 16 bits, okay, for example at Mega 32, the value of the program counter is broken into 2 bytes. Okay, the lower byte is pushed onto the stack first and the higher byte is pushed. Okay, contohlah this is the address. Okay. Okay, sini contoh kalau kat sini ada call. Okay, so this is your instruction. This is the instruction and this is the address of this instruction inside of your program memory. Okay, since this one here, okay, for AVR we are using the little Indian. Kenapa kita panggil dia little Indian? Okay, the way that the address is pushed to the stack or push the memory is by using the lower byte. Dahulu kita masukkan lower byte and then kita letak higher byte. Okay, contohlah. Okay, so sekarang ni call delay. Okay, sebelum kamu pergi ke delay, what happen is, okay, CPU akan ambil address NOP ni letak dalam kamu punya stack. Okay, say this is your stack. Okay, so what happened? Okay, since this is a 16-bit, 16-bit, size yang ni adalah 16-bit. So yang ni kita boleh bahagikan dia kepada 2 byte lah. One is a low and one is high. Okay, the lower byte akan disimpan dahulu ke dalam kita punya stack, which is 13, address 13 akan disimpan kat sini dahulu. And then follow by higher byte. Okay, sebabnya kenapa? Sebab kita guna Little Indian punya approach. Okay, Little Indian means that the lower byte is stored to the memory address followed by higher byte. If you use a bit Indian, the higher byte will be stored to the data memory address then followed by lower byte. Okay, so sekarang kita pakai Little Indian ya. Lower dahulu baru higher. Okay, for AVR whose program counter is longer than 60-bit but shorter than 24-bit, the value of the program counter is broken up into 3 bytes. Okay, contohlah. Kalau that AVR consists of 24-bit program memory. Okay, so apa nak buat? Kamu boleh bahagikan dia kepada 3 bahagian. Okay, so this is a lower, this is medium, and this is highest. Okay, macam mana nak simpan dalam stack? Mula-mula kita masukkan lower, and then followed by medium, and after that, higher. What about your stack pointer? Stack pointer akan decremental lah. Every time you put the address to your stack, the stack pointer will be incremented. Okay, so this is the role of stack for the subroutine, di mana stack digunakan untuk simpan address temporarily. Okay, after the subroutine is finished, then after that, the CPU know dia kena kembali semula dekat location after you call that subroutine. Okay, so why use subroutine? Okay, satu untuk code reuse. Okay, because you're going to reuse the code several times. Okay, so we need to use the subroutine. Okay, easier to understand the code. the code, okay, means that it readability. So taklah kamu punya program terlalu panjang, which is you waste too much of your program memory space. Okay, and to simplify the code debugging process. Okay, so a part of the call instruction, okay, we have another instruction called rcall instruction. Okay, dia macam jump jugalah. Okay, previously you have a jump, JMP. Okay, instead of jump, you have the rjump, ijump. Sama juga call, kita akan ada rcall and icall. Okay, so rcall is a relative call to subroutine. Okay, so this is the rcall syntax. While okay, not much different lah between call and rcall. So usually we just use a call instead of rcall. While icall, okay, is indirect call to subroutine, which is you're going to use the pointer register Z. Okay, so selalunya kita pakai call aja, tak payah pening kepala. Jangan pakai rcall ataupun icall, pakai call subroutine saja. Okay, so any question up until here before we go to subroutine example? Okay, ada soalan tak? Okay, if tak ada soalan, okay, I give you 5-minute break. Okay, 12:15 kan kita sambung semula untuk lihat subroutine example. Macam mana kita nak simpan address, okay, subroutine ke dalam stack, and macam mana kita nak retrieve balik address daripada stack masuk ke dalam program counter selepas kamu guna RET instruction. Okay, use call subroutine for sending the data to port B and another one for time delay. Put time delay between each issuing of data to port B. Okay, so this is the program, okay, which is this program here used to do a counting sequence, which is to count from 00 sampai FF, and then at the same time you're going to send the counting to the port B, and setiap kali kamu nak send the data to port B, kamu kena call a delay, okay, a time delay, and call another subroutine to send the data to port B. So you have two subroutines here, one to send a data to port B, and another subroutine is called a delay. Okay, put time delay between each issuing of data to port B. So this is the solution. Okay, so let's look line by line what happened here. Okay, so include empty2dev.inc. So this is the masalah. Okay, every time you write the assembly language, okay, make sure don't forget to include this file empty2dev.inc. Okay, then we have the .dev count R20. So what this .dev count R20 do? You're going to define your R20 with another name. Okay, you're going to define your R20. Kamu tak nak pakai R20, kamu nak tukarkan nama dia supaya nama dia jadi count. So we use the .dev. Okay, then .org0. So what is .org0 means that you're going to start your program memory. Okay, so this is your program memory. Yang belah kiri ni is your program memory. Okay, so program memory will store all the program that we write in the assembly language. All the program that we write in assembly language will be stored inside of program memory. So in this case here, you're going to store all this program here started at location 00. So that's why you see here, okay, the first line here started with 00, followed by 01, 02, 03, 04, and etc. Okay, so this is the memory address lah. Okay, this is the program memory address for each of this instruction here. Okay, and then okay, we're going to check line by line what happened. Okay, so I draw the program memory dahulu. Sorry, our data memory. So this is our data memory. Okay, then we have a stack pointer. Okay, at the beginning of at the start of our program, the stack pointer value is point dekat address 0000. So this is SPL and this is SPH. Okay, so now what happened here? Okay, you see here load IR16 high ramen. So sekarang ni stack pointer point to this address. This is address 0000. This is 085F. Okay, jangan salah ya. This is a data memory address. But this is the program memory address. There are two different things. Okay, this is a program memory address and this is a data memory address. Okay, at the start of your program, the stack pointer point to this address. Okay, you don't want your stack pointer point dekat GPR, nor in your IO. You're going to make sure that the stack pointer initialize dekat 085F, which is dekat kamu punya RAM N. So how to do that? Okay, by initialize your stack pointer using this 4 lines instruction here. Okay, load I R16 high ramen out SPH R16. So you know that your ramen is 085F. Okay, so this is a low byte and this high byte. So high byte now you put to your SPH. So what happens sekarang ni stack pointer ada 08, which is sekarang ni dia around here. Stack pointer. Okay, but this one here, even though it is point into your RAM, but this is not the exact location lah. Kita nak stack pointer letak dekat 085F. Okay, which is this is also not true lah. Okay, so what happened? Kita load again, load R60 low ramen. Okay, which is 5F. Letak dalam R16 out SPL R16. So what happened here sekarang ni, yang ini akan ada 5F. So now your stack pointer point to this address. Okay, so this is the location that we're going to initialize the stack pointer, which is dekat 085F. Okay, so this is 085D. Okay, this is 085E. 085. Sorry, this is E, D, C, and this is 085 B and 085A, etc. Okay. Alright. So now you already initialize your stack pointer. So your stack pointer now point to this address 085F. Load I count 0. So what happened? Okay, you letak kosong dalam count, which is R20. Okay, and then back call display. Okay, now what happened here? Okay, you have the first one here, call display. Okay, before you go to your display subroutine, which is here. Okay, what happened is you need to store this address. Kamu kena store dahulu address ni ke dalam stack. Okay, which is address kat sini sekarang ni ialah 0007 untuk R jump back. Okay, so what happen here is kamu boleh bahagikan kepada low and high. Okay, as mentioned earlier, okay, to store this address to our data memory, okay, we using the little Indian method, which is kita masukkan 07 dahulu, baru 00. Okay, so what happen here is 07 kamu akan simpan kat sini, followed by 00. What happened to your stack pointer? Stack pointer is decremented, now point to address 085D. Okay, this is what happen when you do the call display instruction. Okay, before dilompat ke display, ambil address yang ni, which is jump back, address of the next instruction, which is 0007, simpan dalam stack. Okay, and then the stack pointer decremented. Okay, dekat display ni, okay, you do lah increment count, output B count, call delay. Okay, now you have another call. Okay, what happened? Okay, before you go to your call delay, which is here, jump to this subroutine, you need to simpan dahulu address ni, letak ke dalam kamu punya stack. Okay, which is address yang nak disimpan ialah 000C. Okay, bahagikan daripada low and high. Okay, 0C akan disimpan dahulu. Okay, 0C and then followed by 0. What about stack pointer? Stack pointer now decremented and the stack pointer point to this address 085D. Okay, then after that it will go to delay. Okay, to do this delay here again, and then do this pressure, and then suddenly RET. So what happened when RET? Okay, when the RET is executed, so the CPU will take this address and put it to the program counter. Okay, so 000C akan di-load ke program counter, and what happened after that? Next, the stack pointer is decremented. Dia akan point to this address. Okay, sebab kita dah ambil yang ni, so stack pointer now point to this address 085D, and program counter menunjukkan address 000C. So now the CPU know that, okay, now we going to kembali ke 000C. This is a 000C. Okay, kita kena kembali ke this address 000C. And when 000C, there is another return. So what happened? This address here 0007 akan diletak pada program counter. Okay, so now the program counter point to address 0007. So the CPU know, okay, now we need to return to address 0007, which is this one here. And then what instruction here? Jump back. Okay, so when jump back, you need to go back to your back and again call display. So this thing will repeatedly happens. Okay, dia akan keep happening. Okay, so this is how the call and return instruction works. Okay, macam mana kamu when the call instruction, the data, the address of the next instruction will be stored to your stack, and when the return instruction is executed, the address inside of the stack will be loaded to your program counter, and then your stack pointer will increment. Okay, so this is what happens every time you use the call and return instruction. Okay, this is the summary lah. Okay. Okay, before call display, what happens? You initialize your stack pointer so that your stack pointer dekat 085F, and then after the call display, you take the address 0007, letak dalam kamu punya stack, and stack pointer is incremented dekat 085D, and then call delay. Okay, you take the address 0000C, put it to your stack, and stack pointer is decremented, point dekat 085B, and then after delay return, what happened? Okay, this 000C kamu letak dalam program counter, and then stack pointer will incremented, point to address 085D. Actually, dekat sini masih lagi ada 0C ya, dia tak berubah. Okay, and then when you execute another return, you take the 0007, put it to another program counter, and the stack pointer now incremented point to address 085D. Okay, so this question is always asked lah in the test or in the final exam. Okay, so let's look at these examples. Okay, so these examples here. Okay, this is a question. Okay, one of the question asked in the final exam, if not mistaken. Okay, answer the following question with assembly program below. Okay, you given an assembly program. Okay, and this is the we call here the address of this instruction here, program memory. Okay, state the content of the following table after this assembly program is executed right after the instruction RET. Okay, sampai RET je kamu stop. Okay, no need to do all the other thing. Okay, sebab dia kata sampai right after. Okay, okay, you need to give the content of the table right after the instruction RET. Okay, the uppermost memory location is the address 08 5F. So this is the table. Okay, you need to fill in the what is your R26, R27, R28, and then program counter, stack pointer, as well as your memory, data memory address. Okay, so this is 085F, 085E, 085D, 085 C, and 085B. Okay, so this is the box yang kamu kena isi lah nanti. Alright. So let's look how to solve this. Okay, let's find out what are the answer after you execute the RET instruction. Okay, so let's look line by line. Okay, so these 4 lines here, what happened? You're going to initialize your stack pointer so that the stack pointer point to your RAM N. Okay, so what happened after you execute this line here, stack pointer point to here. 085F, your RAM N. Okay, then load I R2635, so kamu letak 35 dalam ni, R26. Load I R27 89, 89 kamu letak dalam ni. And load I R28 48. So 48 dalam R28. Okay, then after that, push R26. Okay, you're going to push your R26. So what happened here? When you push R26, value R26 which is 35, kamu simpan dalam stack. What happened to your stack pointer? Stack pointer decremented. Okay, saya tak tulis lagi stack pointer kat sini sebab kalau tulis nanti setiap kali dia changes, saya kena tulis. So no need to put the stack pointer and program counter lah because this one dia always berubah-ubah. Okay, setiap kali kamu buat dia akan berubah-ubah. And then push R27. What happened? Take the value from R27, simpan dalam stack. And stack pointer decremented. Okay, and then push again R28. So what happened when push R28? Okay, value 48 dalam R28, letak dalam stack and stack pointer decremented. Okay, dekat sini, you see here call modify. Okay, so what happen when you do the call modify? Sebelum kamu pergi ke modify punya subroutine, okay, you need to store the address of the next instruction dalam kamu punya stack. Okay, which is sekarang ni address yang kamu nak kena simpan ialah 030C. Okay, since 030C is a 16-bit, kamu boleh bahagikan dia kepada low and high. Okay, ingat lagi yang mana kita akan simpan dahulu, low dahulu kita simpan baru kita simpan high. So that's why kita simpan dulu 0C kat sini, baru follow by 03. What happen to your step pointer? Step pointer now point dekat address 0858. Okay. Then after that dia akan lompat ke modify. Okay, so dia akan masuk modify punya subroutine. And after that, apa nak kena buat? Okay, then STS 085D R27. What this STS do? Siapa nak tolong? STS, buat apa STS ni? Semalam ada buat kan? Masa test STS. Apa STS buat? Anyone? Nazra? Nak tolong share ini? What did STS do? Paling senang ni. Cepat-cepat. Apa yang STS buat? Okey, Ahmad Kai. Ada nak bantu ke?
Dia store direct to data space.
Okay, so dia akan store value daripada R27 ke address 085D. Okay, value R27 adalah 89 and kamu nak store dekat alamat 085D. Dekat mana 085D? D is 085D. Okay, so sekarang ni no longer ada 48. Sekarang dah tukar jadi 89. Okay, and then STS 085E R28. So sama jugalah. You're going to store direct daripada R28 ke address 085E. What is R28? 48. Nak simpan kat mana? Dekat alamat 085E. So sekarang ni value kat sini berubah daripada 89 jadi 48. Okay, kita dah buat yang ni. Okay, next. ADD R28 R27. Okay, what happen here? ADD R28 R27. Yang ni paling simple kali ni. Kamu nak buat operation apa tu? ADD R28 R27. Anyone?
Tambah
Okay, tambah. Tambah apa dengan apa?
R27 tambah R28.
Okay, R27 tambah R28 dan simpan hasilnya ke dalam
R28.
okay, R28. So 89 tambah dengan 48. Okay, kamu akan dapat D1. Simpan hasilnya dekat R28. Okay, so R28 sekarang ni dah berubah value dia dah berubah jadi D1. Okay, next. RET. Kita kena buat RET. Okay, so kalau soalan ni dikata kat sini. Okay, stop after you execute the RET. Means that lepas dia akan execute RET, stop. Tak perlulah kamu buat yang ni. All this thing here, no need to do anymore. Okay, just stop after you execute RET. So, what happen when you do the RET? Apa yang berlaku bila kamu buat RET? Okay, so RET apa yang berlaku? Yang ini, address yang ini, 030C akan dimasukkan dalam program counter. Okay, so 030C akan disimpan dalam program counter. What about your step pointer? Step pointer sekarang ni akan point, previously dia point dekat 085A kan. So sekarang ni dia point dekat address 085C. Sebab dia ambil dua ni. Dua so dia kena increment dua kali lah. Satu. Okay, satu. Dua. So kat sini step pointer kamu berada. Okay, so what would be the final result? Okay, so the final result will be okay, R26 akan ada 35, R27 89, 28, D1, okay. program counter 030C, stack pointer 085C, okay, address dekat 085B masih lagi ada 03, and this one ada 0C. Okay, kalau kamu letak 00 pun saya terima. Okay, kalau kamu tinggalkan 030C pun saya terima. Okay, by right value kat sini tak berubah. Okay, masih lagi ada. Cumanya stack pointer je yang incremented. Okay, and then 8D kita dah berubah jadi 89, 085E jadi 48, 085F 35. Okay, so this is the final value. Okay, this is the answers. Okay, if you got all this correct, kamu akan dapat 10 markah. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Setiap satu ni 1 markah. Okay, another exercise. Okay, given a program sequence, okay, yang ni pun soalan final ni. Okay, based on the program sequence below, find out the result of the affected register or memory addresses. Assume the program has properly initialized the stack pointer to address 085F. The instructions are executed sequentially. So, dia dah bagi kat situ initial value R16 kosong, R17 kosong, R18 kosong, 19 kosong, 20 kosong. Stack pointer dah initialize dekat 085F dan stack content dekat 085F ialah 00. Okay, so macam mana nak buat? Okay, saya suka lukis kita punya data memory. Untuk stack pointer, okay, untuk soalan yang ada stack, better kamu lukis kamu punya data memory. Okay, so that kamu nampak dia punya pergerakan dia. Okay, so yang ni 085F. Yang ni 085E, 085D, this is 085C, 085B, and this is 085A. Okay, dia dah bagi tahu kat situ stack pointer sekarang ni point dekat alamat 085F, di mana stack content sekarang ni masih lagi tak ada, kosong lagi. Okay, so let's look line by line apa yang berlaku. Okay, load I R16 5. So what happen sekarang ni? Okay, 5 kamu letak dalam R16. So by right jawapan kat sini kena dalam hexadecimal ya. Okay, so hexadecimal kamu tulislah 0, 5. Okay, all the value inside of our register, our stack pointer, or our stack must be in hexadecimal. Sama juga dengan yang atas ni. Semua value kena dalam hexadecimal. Kalau kamu letak dalam jawapan decimal, the answer will be wrong. Okay, jawapan kamu akan salah. Okay, so this is what happened. Load I R16 5. Okay, 05 akan masuk ke dalam R16. What about the others? Okay, since yang lain value-nya tak berubah, so kita tak perlu isilah. Okay, mana yang affected je kita isi. Okay, mana tak affected, kita biarkan dia macam tu je. Okay, dan kamu ada simpan push R16. Okay, what happen when you push R16? Okay, so sekarang ni R16 kamu sama dengan 5. Okay, push R16. So 05 kamu masukkan dalam stack. Okay, what happened to your stack pointer? Stack pointer decremented. Every time you do a push, stack pointer will decremented. Okay, previously stack pointer point dekat address ni, betul tak? So sekarang ni stack pointer dah decremented. Okay. Okay. So stack pointer sekarang ni point dekat 085E. Okay, then kamu decrement R16. Okay, what happen when you decrement R16? R16 sekarang akan jadi 4. Okay, branch not equal simpan. Okay, apa akan berlaku? Selagi R16 tak sama dengan kosong, dia akan pergi ke lompat ke simpan. Okay, lompat ke simpan buat apa? Push R16. Simpan lagi value R16. R16 sekarang 4. So letak lagi 04 dalam stack pointer decrement by 1. Decrement R16. R16 jadi 3. Branch not equal. Masih lagi tak sama kosong. Pergi ke simpan. Push R16. So 03 letak pada stack. Stack pointer decrease. Decrement R16 jadi 2. Lepas tu masih lagi tak sama kosong. Pergi lagi ke simpan. Push R16. So yang ni jadi 2. Decrement R16 dia jadi 1. And then branch not equal. Masih lagi R16 tak sama kosong. Pergi lompat lagi ke simpan. Push R16. So 01 letak dalam ni. Okay, so sekarang ni stack pointer dan decrement jadi kat sini ya. Dia dah point dekat alamat 085A. And then decrement R16. What happen when you decrement R16? R16 dah jadi kosong. So kat sini nanti kamu akan update. Yang ini kosong. Yang ini 01 and stack pointer sebab lepas tu dia dah tak melompat lagi kat sini ke simpan. Sebabnya sekarang ni R16 dah sama dengan kosong, dia akan buat next instruction. So kita stop kat sini. So stack pointer, what about the stack pointer? Stack pointer now point dekat alamat 085A. What about stack content? Stack content dekat alamat 085B. Okay, kamu tulis je 85B ada value 01. Okay. Boleh follow ya? Any question up until here? Ada soalan tak? Okay, yang ni kamu kena ni lah. Kena tengoklah kamu punya ni. Sebab kita ada ni, branch not equal ni. Okay, kamu kena refer balik modul 7. Saya dah bagi dahulu video untuk modul 7. Macam mana nak tengok program flow. Okay, kamu ada jump, kamu ada branch instruction. Okay, how this branch instruction works. Okay, so since sekarang ni R16 dah sama dengan kosong. So yang ni dah tak valid. So once tak valid, kita kena buat next instruction. Which is pop R17. So what happen when you pop R17? Okay, ambil content daripada ni. Okay, content daripada stack letak dalam R17. Okay, so 01. Tak nampak pula ini. Okay, 01 letak dalam R17. What happened to your stack pointer? Stack pointer decremented by 1. Okay, so stack pointer kat sini tunjuk 085B. Okay, sebab kita dah pop tadi, letak kat R17, so automatic stack pointer decremented by 1. Pop R19. So what happen pop R19? 02 ni nanti kamu masuk ke dalam R19. Okay, and then what happen to your stack pointer? Stack pointer incremented by 1. So sekarang tunjuk 085C. Okay, pop again. Ambil lagi. Sekarang ni 03 pula. Jadi kita dah ambil 02. Sekarang ni kita ambil 03 daripada stack. Letak ke mana? R18. What about your stack pointer? Stack pointer incremented by 1. Okay, so sekarang ni dah point dekat 085D. And last but not least, pop once more. Sekali lagi kamu pop. Okay, R20. Ambil 04 ni letak dalam R20. What about your stack pointer? Stack pointer increment by 1. So sekarang ni dia jadi 5. So this is the final stack pointer lah. Okay, this is your stack pointer. Okay, so this is the final answers lah. Okay, kalau kamu betul yang ni, kamu akan dapat 10 markah. So this is for the stack. Any question about the stack and stack pointer? Okay, kita dah habis modul 8. Which is kita dah habis assembly language. Petang ni kita akan masuk C programming. Ada soalan tak? Any question, guys? Okay, if no question, okay, we stop here. Okay, and then kita sambung semula pada pukul 2:30 petang. Boleh 2:30 Okay, thank you guys. And see you after the pukul 2:30 petang.
Thank you, Doctor.